Greetings and welcome to my new calculus channel. My name is John Gabriel, and I'll be continuing to discuss some of the important concepts of number in this video. Now, I began discussing this idiot's real analysis textbook. This idiot that you're looking at in front of you is Terence Tao, a non-mathematician who won a Fields Medal and basically just a stupid moron, like all the other morons in mainstream academia. Now, he says that you can define natural numbers, or any number really, beginning with the Peano axioms. So he tries in this bowel movement of his, which is called real analysis. He tries to define numbers, and what he does is he begins with Peano's axiom. So what did Peano's axiom say? Let's see. Peano was another prize idiot. He said that zero is a number. So, well, first of all, what if you don't know what a number is? Well, yes, then you could call yourself a moron, but you can still call yourself a moron because I claim that you don't know what a number is. Okay. And I claim that Terence Tao doesn't know what a number is either, even though he's won a Fields Medal. Doesn't mean anything. None of his colleagues also at his university where he works or any of the other Ivy League universities have a clue what is a number. And turns out you don't really need to know what is a number when you use bullshit like they do. And that's why mathematics hasn't really gone anywhere in the last 150 to 200 years, except for my work, which is the new calculus and the new knowledge that I have shared with you online. Now, zero is a number, it's just utter garbage. And if A is a number, the successor of A is a number. So now, not only do you need to know what a number is, but you need to know what a successor is. And it says, using this idiot's definition, Peano, Tao says zero is a natural number, and if n is a natural number, then S of zero, by the way, it's not n plus plus. You're not dealing with a programming language here. And of course, I used to be a programmer, so yes, this is similar to this, but it doesn't actually prove anything. Okay, it doesn't say anything about the successor of this object here, which is introduced as a natural number. In fact, we don't know what number is, never mind what natural is. So then he says, for instance, from the second axiom, and two applications of axiom 2.2, in other words, from this axiom, if A is a number, the successor of A is a number, then he says that we see that this here is also a natural number. No, we don't. We just see a bunch of drivel here. You don't understand anything. You think you understand, but you don't. You see, a lot of machinery went into the realization of number by the ancient Greeks. So I've already shared with you my brilliant article, Realization of Number, which is over here. This is how the Greeks, this article here, I've already shared that with you. It shows you exactly how number is realized. There are no assumptions. There's no bullshit like decrees that you find in Peano's axioms. Zero is a number. Since when? And what the fuck does a number mean? Okay? So, of course, little parrots like Terence Tao don't really know any better. And they get to where they are because they know how to lick ass. Okay? I wish he'd have a photograph with his tongue out. It would probably be brown. Okay, well, that's a little crude. But anyway, now, so axiom is a belief. Okay, so you just have to believe this. And you don't, how can you believe in something that you don't even understand or know? If I don't know what a number is, if I don't have an exact definition of number, how am I even going to know what a natural number is? And then the second axiom builds on the first one. It says if n is a natural number, then n plus plus, what it means is n plus 1. So now, not only do you have a more complexity in terms of an arithmetic operation, but you're saying something about numbers and arithmetic. How's that so? Well, look here, n plus 1. That has the same effect as n plus plus. Okay, exactly the same effect. So if you say one plus plus, that'll be two. Okay, that'll be two, and that's the same as one plus one. Okay. Now, not to spend too much time on this idiot because he waffles and carries on, and he's really a very stupid academic, just like his colleagues and all the other MIT and Cambridge and those fellows. So let's get to the point now. So you really need to just toss this shit out of the window because the foundations of mainstream mathematics is based on this crap. And so who came up with it? Well, let's see who came up with it. So let's open this up here. If we take a look at this diagram here, this is what the Peano derivation is. It says, let 0 be a clown. Then the number 1 is contained in a set, whatever, Just have to believe that. So 0 is a clown, and 1 is a clown in brackets, and 2 is a clown in brackets and just a normal clown, 0, 1. Okay. So this is the utter and absolute drivel that you get in mainstream math academia. They don't understand number at all. There is no understanding whatsoever. Hasn't been before I came along and after Euclid. Okay. After Euclid and before I came along, those morons did not understand number. If they do know of another way to derive number now, they've learned it from me. Okay. A number is a name given to a measure that describes a ratio of magnitudes. It's that and nothing else. Okay, it's not this garbage that you see, this von Neumann derivation. I mean, this is a joke. That's why you see clowns. And guess what? If you do this derivation up to 6, the number of clowns here happens to be what, do you think? That's right. It happens to be 40, which corresponds to the Bourbaki clowns who actually decided that they're going to use ZFC axioms as a foundation. When one doesn't understand, I suppose belief is the next best thing, right? So, okay, now let's get back to the essence of what I'm trying to tell you. Number is a complex, very complex concept, okay? And the only way you can derive, and it's not evolution of number, it's a realization of number. I should have changed that. But anyway, the only way you can realize number is this way that I've shown here. You begin with the primitive concept of a magnitude. Then you have a ratio. Then you realize that the unit is possible as a physical measure of a ratio of two equal parts. And then this is a very difficult concept. Step 4. So you have to study this very carefully. Mainstream Greek academics have never understood this. They're also a bunch of morons because they were trained at Western universities, but they don't even have a word in a description for the word quotientness, which is a Greek word, in their dictionaries. If you say pilikotita to them, they don't know that it means quotientness. They don't even know what that means, period. So they are like you and your mainstream, your Western colleagues, a bunch of morons. So the next step is the realization of natural number. 6 is a fraction, and 7 is what you think of as an irrational number. It's not an irrational number because this kind of ratio has no measure. So what do we do if we attempt to measure such a ratio and it converges? We call it a constant. Okay. So we call pi a constant and we say, oh, let's use 3 or 3.1 or 3.14 or something up to 20 places, right? So a lot of this ignorance in mainstream mathematics comes from a profound misunderstanding of number and arithmetic. So you don't get number until you have arithmetic, okay? So once you understand arithmetic, and I have an excellent article here, by the way, it's called Gabriel Arithmetic Without Numbers, and nobody in the history of humanity knew this. It's my method. Okay, I realized this, and I show you how to do arithmetic without numbers, which means that if you really want to understand what you do when you're using those symbols in your mathematics, you need to study this article. It's the most important article in arithmetic ever written. And it's not about numbers, by the way. Arithmetic. Here's another thing: you can't just define arithmetic and numbers as that idiot that I debated a couple of days ago. It's not something as what most of you numbskulls will think of as intuitive or whatever. It's based on fact and reason. And that's the only thing that you can base mathematics on. You can't base it on axioms because axioms are a bunch of crap. And by the way, the five requirements of Euclid are not axioms, and there is no such thing as a parallel postulate. The fifth requirement of Euclid is not even about parallel or non parallel lines. It doesn't matter what two lines you have that are cut by a transversal. The result is not about parallelism, has nothing to do directly with parallelism. Okay? So I'll make a video on that at some future time. But the Bourbaki morons didn't realize this either. They didn't understand Euclid. Yes, sure, there were errors in Euclid. Not errors. How can I say it? They're not really errors. They're not the best way of defining things. For example, I mean, when you define the unit, you don't say unit is that by virtue of which all things are one. I have a better definition in my article. So read this. And also, I have a tribute here, which you can read. It's called The Theory of Fractions from Book 5. So, in fact, Theory of Fractions, it explains all these things. Here it is, this book here. I'll put a link to that for you as well. So this here teaches you all about how you got fractions, how you manipulate them, and it tells you things that you've never known in your entire university or school life. So if you want to really understand, you need to read this. Okay, it's not easy. It takes a bit of time, but it's worth the effort. So, what about the precedence order of arithmetic operations? Well, I think you may have recalled that I said the first possible arithmetic operator is difference. From difference, we get sum. We cannot get difference. You can go this way, but you cannot go this way. Okay? Cannot. And of course, this is another proof that moronic morons of mainstream mathematics academics did not understand, do not, and never have understood arithmetic because they think of addition as being the first operator. It's wrong. Difference is. Then from these two, or either one of them, you get what's called the primary measures. Okay, division. Division is the same as measure, by the way, exactly the same. And it means you measure one quantity in terms of another. Okay, so when that little idiot uh, who got on to my channel and drew and said 3 divided by 1. By the way, I've never said 3 divided by 1 is not 3. He drew 3 blocks like this, the idiot, calling that 3. And by the way, that's okay. And then he measured it like this by saying this is 1, 2, 3. That's correct. But that's how I would teach children. And I do have a book on that. It's called, let's see, it's called You Want to Make Your Toddler Brilliant? It's this here, Unlocking the Mystery. This here teaches your toddler how to do all the arithmetic operations with just one prerequisite, the ability to count 1, 2, 3, 4, 5. Okay? That's all you need here. And I would download that article. It's free. You have to create a free account on Academia to access it, and you also have to log in. So, and now the final operation here, let's get rid of this drivel now. The final operation is multiplication. It's the most complex because it says P is measured in terms of 1 over Q. Okay? P is measured in terms of 1 over Q. So this is multiplication, by the way. So we go from these two, excuse me, these two to division, and from division to multiplication, because this is the same as saying P times Q, isn't it? All right, now, why can't you say something like I said over here? Let's see. So you'll look at this article of mine, which I'll place a link to, and you'll say, but wait a minute, 13 divided by 5 is the same as 13 times 1 over 5, and you're using multiplication. True. But look at this term here, 1 over 5. How did you get that? You had to first use division, right? Don't be stupid. Okay, so you cannot define division in terms of multiplication. It's impossible, all right? And I put this in today because I saw for some reason some people are still not getting this. So uh, I know I'm a genius IQ, but when you have a genius IQ, you think that people will be able to put one and one together at least, but they're not. So okay, now that's pretty much it. I think I've gone incredibly long already. I didn't want to go on that long. In fact, I like to keep my videos short. I'll place a link to all these articles. If you're not already a subscriber, become a subscriber, click like, tell your friends about it, tell your teachers about it. And yes, also become a follower on academia. You can follow me on academia to get access to all my free articles here. And there's one really excellent book here which I offer free with a watermark and which I sell at about $10 on Amazon without a watermark. I'm John Gabriel, and this is a new calculus channel. Till next time, goodbye.